Quick tech demo. So we've talked a lot about immutability, idempotence, resiliency in face of failure, cloud servers, accelerating velocity, and so this is a demo about, what you get if you do that stuff. Who would like to pick a number between 1 and 6? 3. Who would like to pick another one? 2 many. Race condition. What? 1. 1 and 3. Okay. You sure? So this is production. This is JustEats consumer API, which I own. Well, me and a team. And as you can see, I'm very blasé about the fact that I'm just raising a third of our capacity to the ground. Who can tell me when our load comes along in JustEats model? Sorry, we do online takeaway, so that's a hint. Anyone? Sorry. Around dinner time, yeah. The model is roughly, hi, do you fancy a takeaway? Don't really fancy cooking. It's been a really long day. Yeah, great. Oh, just eat. So that's really what it is. We've been in the cloud, in the AWS cloud for, I guess Q1 2013. We've been running this demo in production. I guess this is production for the demo for about 2 and a bit years. So, any idiot like me can get up on stage and tell the people on the rotor that they're doing this, but then go and do it. And we're pretty confident that in about 20 minutes, those 2 servers will be replaced by totally clean, fresh cattle for the pod. And if we're really lucky, then my phone will make an obnoxious noise, but it's still before dinner time, so we're not seeing much load. We made a few decisions at the start of the migration. So this is me telling my team I'm doing this. We made a few decisions at the start of the migration. We want to have losing a server to not be an event. There's no human in the loop to replace these servers, because that's really dull. It's the 21st century. I want my servers, please. We're in the cloud, so let's use it. We also made the decision that we want to be able to weather the loss of a single availability zone within the Irish region of AWS. There are three AZs there. If we lose one, we want the customer to not care, to not notice. And so I just terminated 1/3 worth, simulating an AZ outage. And yeah. Let's just have a quick look into the monitoring and alerting room. Amazing, nobody cares. So really, that's the demo. We can wait around for the remaining 15 minutes and the servers will come back, but the point of this exercise is this is a really dull thing. This is business as usual. Things fail. Things in the cloud especially fail. If you look really closely at the SLAs, they don't really give you an SLA about the fact that the failure rate is X. They just tell you, don't put your data on the servers, and so don't put the data on the servers and manage your data as, well, care about your data. Care and feed your data. So you can also see some stuff happening in this room. It doesn't really show up so well on the projector, I'm afraid. Siren alerts, so that's our monitoring system, our alerting system on top of our monitoring system. We recruit developers, and then we teach them that operating in production, you just have to write a different type of test. Those are checks that trigger alerts. So rather than CI going red, you now have a monitoring system that goes red, and it gives you an obnoxious page on your PagerDuty that you carry in your pocket. So these are continuously running tests. They execute every 30 seconds or whatever it is. And they just tell you that production is within tolerance. Because that's another difference between production and your workstation and a unit test. A unit test is a binary pass or fail. Production is, well, there are customers there, right? So there's chaos happening. And you cannot really reason about chaos very well. So you have tolerances of what good is, of what green is, compared to red. If there are any questions, shout them out. No, you're the first person to ask that in 2 years. Oh, there's no internet. No. There's no internet connection. We will turn off and turn on the Wi-Fi of my computer. If you would like to browse to Just Eat on your phones, however. No, my network's not playing. So that's really interesting. I can get to HipChat, as you can see, because stuff is happening. I can kill things in prod, but I can't actually go to websites. So I can get to Google. Here we get into, okay. So it's not just me, it's probably something network related. If you'd like to wave your phones in the air with Just Eat's homepage, please. Okay, and then log in, because I killed the consumer API, which is the logging in part. So, but yeah, I'm confident. I can see HipChat, and if I were able to get onto the VPN, then I'll be able to show you some charts that prove the confidence. And actually, I can go to AWS's monitoring and show you what's going on. So I expect there to be 8 instances now. The first and third in the stack are initializing. So this is AWS saying, oh yeah, we want you to have 6 instances because you told us that's what you want. I've noticed that you've been an idiot on stage and killed 2. Let's give you 2 more. So that's what's happening here. So we have now the provisioning time of the cloud resources, and then the bootstrapping time of our automation that gets kicked off once they've booted, and then they're ready for business. And then that's the only thing we do to instances in the general case. They bootstrap with our software, and then we kill them. That's really what they have to expect from life. It's a very sad existence. But they get to be connected to Just Eat, so it's not all bad. Any other questions as we wait for the boring part of the demo? Tough crowd. We got an awfully long way into our AWS, our cloud computing experience before we realized that configuration management might be a thing. Back in 2013, we created an AMI, an Amazon Machine Image, by hand, and captured that as an AMI. And that's what we used for the longest time to actually launch instances here to be web servers or worker servers. So there were a couple AMIs. That turned out to have been good enough for us to use as infrastructure. And then out of a hackathon, somebody came up with the bright idea that maybe we could get the computer to do the building of the AMI. So now we can have repeatable builds that are generated by Team City. Amazon is kind enough to send us a notification whenever they update their AMI. And so we use that as the trigger for the Team City builds to produce ours. And so now that's modern and better. But we didn't need that. A lot of the stuff that you've heard today, they are pick and mix from different toolboxes. And your context is your context. I don't know what that is. For us, it was good enough to run without tests and a bit. You live only once. For you, maybe, it's up to you. I'll just refresh this. So we've got one of them that's passing its status checks. So that means that Amazon can see it, and Amazon is reasonably sure that its power is on. In a few minutes, our software will install, and you'll see the J feature version and J position fields be filled in, and that's enough indication that, to me, to be confident that they're happy again. And if they're not, then Amazon will notice, because there's a health check going on every 30 seconds. So say, are you ready yet? Are you ready yet? Are you really ready? Not ready yet. And if they take too long, then they will in turn be killed. This is the load autoscaling group view. So autoscaling is one of the best cron jobs ever invented. It sits in a loop and goes, do we have the number of servers that we want? Do we have the number of servers that we want? Ah, no, you don't. Let's launch some more. Or, no, you don't. Let's kill some, because we can go up as well as down. We optimized for costs in a very crude way, and there are many more optimizations we can make. But essentially, because we have that really predictable demand curve, people get hungry at 5 and stop being hungry at 9 for us. That's pretty much every day. We decided rather than go to the complexity of getting autoscaling to react dynamically to the load that's on our services, we would just scale up at 4 and scale down at 10. And so immediately you cut out that chunk of the day where there's not enough traffic to justify lots of servers, and you scale up in time for the traffic, and you scale down at the end of the night. So you get a demand curve that looks like that, which is better than one that looks like that. Again, everything is an incremental optimization, and at some point we might get the computer to notice when there are spikes. The talk at the end of the day is also about, we run fake load to prove that we can take higher capacity, and we've added a release valve, but I won't get to that because that's later. Lastly, everything is in a load balancer. So again, Amazon Services provides an elastic load balancer. We can see here that 4 instances are healthy, and that's the URL to go ping to find out that they are healthy. We can see that there's quite a lot of monitoring. So here's where I came along and killed some stuff. Here's the average latency across the operations being served. Some, traffic counts. So you can see there's a reasonably flat line. Traffic hasn't gone away, but we haven't had a spike of server errors, and we haven't had a spike of 400s. So running so that we can lose a third of our capacity means that the remaining 4 are running hotter, but they're still running. So we're good. Any questions at this point? Yes?
You want to operate in a number of countries.
Yes.
Do they use the same model across? And how's that driven?
So the question is, we operate in a number of countries. Do we use the same model across the countries, and how is that driven? So we quite like having the ability to shoot a server in the head as our first debugging step. So that's an incentive to use this. We have, roughly speaking, 2 core platforms, one slightly behind the other for reasons. And we have the platforms that we have acquired over the years of doing M&A. The platforms that we have acquired, we are gradually consolidating into our core platform. And both versions of the core platform are operated in this manner. So it doesn't make sense to operate in a different way just because they're a little bit behind the code base in terms of features, or the UK has this set of features, and the other countries like Canada or Denmark have a different set of features. They're still operated on the same infrastructure. They're still deployed using CloudFormation to define our AWS resources. Most servers sit in an autoscaling group. That's just the simplest thing. Did that answer the question? Cool. Any others? Yes, at the back.
I saw you're happy to get all the APIs. Can you do the same today?
No, not yet. So we run a SQL Server mirror in the cloud, and that's very entertaining. I guess it's not cutting edge for SQL Server, so it's not the latest version. We're looking at changing that, so it is. And we don't run a Windows domain for any of our e-commerce operations, because we decided that actually that's too hard. Because as you can see, servers come and go, well, regularly, both for planned things and for unplanned things. We count this as a planned thing, just to be clear. And some of the automation that would need to write and manage around computers joining and leaving in a non-graceful way and interacting with an Active Directory, we just decided to not do that. We may revisit that over time, but we haven't really felt the need to do that in the last 3.5 years. And I don't know that there are any plans to really decide that that's a bad idea and we'll change our ways. All of the deployments happen via a pull model, so not a push model. There is no central thing that tells an instance, go be a consumer API now. It all happens by bootstrapping, kicking off an event. That event runs the cfn init command, which is a Windows service that goes off to CloudFormation and says, what shall I be? And then config management happens. One of those pieces of config management is kick off the code deploy agent, which is another AWS service that says, I am going to be a consumer API, give me stuff to become a consumer API from S3. And it's really the simplest thing that we could come up with, and we tried a few things. So that gets us to the point where we have repeatable instances, repeatable infrastructure, and we also have code-based deployments. So a deployment used to be, let's take the autoscaling group, let's put the new version in the bucket, the S3 bucket, the zip file in the bucket. Let's double the size of the cluster. Let's wait for the new instances to come online and be healthy and start serving traffic in the elastic load balancer. And then let's halve the size of the ASG again. And we know that autoscaling will remove the oldest instances first, because we configure the autoscaling group that way. So there's zero downtime deployments with no real moving parts other than a poll and wait against the elastic load balancer instances and service count. So that's very simple. And that's served us up until the last 3 months or so when we started to use AWS Code Deploy. How am I doing on time? Done for time. So, we're almost there. As if by magic. Couldn't have planned it better. Okay, yeah, that's me. Got talk at the end of the day, but this is the demo.